Okay, class, so this is the third part in our series of the story of X. And today, or I should say for this particular part 3, we're going to start off an equation that reads, let's see, hopefully I can find it, 30 equals 10 minus 5x. Right? Okay. Now, one thing we talked about in part 2 was that when we have x on the right side of the equal sign, just because we want to be consistent with the way that we've been solving it, we're going to practice this thing of switching whatever expression's on this side and rotating it to the other, and then rotating whatever expression or quantities on this side and rotating it to the other side of the equal sign. So let's go ahead and do that. We're going to do this, create another equal sign, and then go 10 minus 5x equals 30, and of course originally we had 30 equals 10 minus 5x. I'm having to write that really large, right? Okay, so this is something that you guys are probably a little bit more comfortable with, except you're going, wait a second, Miss Chang, I recognize it if it was like in this form, negative 5x. Oops, my 10 keeps escaping from me. Plus 10 equals 30. I can understand all this because we did this in part 2, but this is what's tripping me up here, because if I were to create and build a story of x, I would be like, okay, what's happening to x first is that it's being multiplied negative 5, but then I'm like, oh, what's happening with this 10 out here? Well, the reason why I've already taken this out for you guys is that if you look at 10 minus 5x and negative 5x plus 10, what does that remind you of? It's a certain type of property that allows us to reorder different expressions or different terms around in an expression. That is the commutative property of addition, right? So again, even though 10 minus 5x is a subtraction problem, we know that we can also write it as 10 plus negative 5x, right? And I'm just going to write equals 30, so we're not leaving 30 behind. But notice that now this is an addition, and because now it's an addition, we can switch around the order, and we can put the negative 5x here, and then we can put plus 10 here, and that becomes really clear for us as to what's happening. And then we like build a story of x and undo it just like we did in part 2. And if you guys forgot how to do this in part 2, I'm going to direct you guys to part 2, just because we have so much to cover in part 3, okay? And technically, guys, you could leave it this way. You could even leave it this way. But a lot of times we find that with students, they don't really know what to do with this 10. And the other thing that you can think about if you want to keep it this way is to say that, well, this is a positive 10. And if I want to undo or take away the positive 10, then I just have to add a negative 10 or subtract 10 from it. And then you would subtract 10 from both sides and do all that. But hopefully this has just kind of helped you to see how you can rearrange it so that it's in the form of an equation where the maybe the variable is the first thing that you see on the left side, and then whatever is being added or subtracted or what else is happening with the constant there equaling another constant. Okay, so hopefully that works. So I'm going to move on from this, and I'm going to start with a fresh piece of paper just so that we don't run out of space. And this time I'm going to give you an expression that reads this way. It's going to read 4x plus, let's see, I'm going to move it further, plus 9, right, minus x. I'm going to leave that as a negative x because I really do want you guys to get accustomed to always thinking about whenever you see a negative and an x, and then there's nothing in between, that it's understood as 9 minus x, okay? So anyway, 9 minus x equals negative 1, okay? So one thing that we can do here is go ahead and again apply that whole step 1, which is simplified form or expression. And clearly what we can see is that on this side of the equal sign, this expression is not simplified. Why? Because we have two sets of unlike terms, but we have 4x and negative x, which are like terms, and we know from all the lessons that we had before we started solving algebra that when we have like terms, we want to simplify by combining them. So we could reorder them and go negative 4x minus x plus 9, right, equals negative 1. So I'm going to do this. Hold on a second. I'm going to do this, actually. I'm going to do this. I'm going to rearrange it this way. And you can rearrange it however you want. You know, sometimes you put the variables together. Sometimes you have the constant after the variable terms, whatever. But anyway, sorry, I don't want to confuse you guys. So anyway, what I've done is I've used the commutative property to rearrange and reorder so that I have the like terms next to each other, and of course we know to regroup them using the associative property, and then the simplified form is going to look like this. Okay, so the solution, of course, on this side, so we're going to say now it's going to be 9 plus 4x minus x is 3x equals negative 1. Okay, so now our simplified expression, once we've combined, so here what we've done is combine like terms. Within an expression, and I wanted again to emphasize this because you're probably seeing these two constants, but remember they're on opposite sides of the equal sign, so we're not really thinking of combining like terms, because in order to combine like terms, expression has to be on the same side of the equal sign. Okay, so we've combined like terms within an expression, right? Within an expression meaning the expression on one side of the equal sign, and what we end up with is 9 plus 3x equals negative 1. And again, going back to that first part of this particular lesson, we said we like reordering so that whatever is being multiplied to x comes first, because that's what we're used to. So now it's going to be 3x plus 9 equals negative 1. So once again, just to clarify, this is the same as this. I've just switched the orders around. So when we apply the story of x, it'll just be a really nice, neat sort of story that we're building. Okay, so let's go to step 2. And we will say build story of x. Become really good at this so far. I mean, not so far, but by now I should say. Okay, so we're going to build the story of x. First, it's being multiplied by 3, and again, the arrow we build up, remember? And then we're adding 9, right? Okay, and then to undo it, we would subtract 9 from both sides, remember? Because if we want to isolate, we want to keep that, undo it, but we have that equal sign demands that whatever we do to this side, we do to the other side. And we're going to divide by positive 3, and then we'll be able to solve for x. So let's do this then. We'll come up here. I'm going to rewrite it right here just so we can keep everything visually just so. Okay. All right, let's do this. So we are going to subtract 9 from both sides. And then 9 minus 9 is 0. So we just bring the 3x down because we haven't done anything with the 3x. Again, this line reminds us that whatever we do to this side, we do to the other. Now we got negative 10. We're going to divide by 3. We're going to divide by 3. And x is equal to negative 10. That should be a 10 over 3. And we can leave it in this fraction form, guys, because it'll just be a lot easier for us to work with. And so you don't need to make this into a decimal. I mean, what we really wanted to check was whether or not the fraction was in the most simplified form, and it is. So we're going to keep that. So we can, of course, check our work. Check. right? Check. And I'm going to go into this simplified expression and put it in and check. And I mean, if you really want to be precise, what you could do is you could put negative 10 over 3 for each of these x's, substitute and work it out. But then we're going to be dealing with a lot of messy fractions for this one. So I'm just going to keep it as is, as that simplified expression, because it was a pretty easy simplification, right? Because we know for sure 4x minus x is 3x. And we're just going to plug things in. So 3, and remember, 3 this time we're saying x is what? Negative 10, the third power. I mean, not, what am I, third power? Sorry, I'm confusing. I was thinking of 8th grade math for a second. Sorry. Let me say that again. 3 times negative 10 over 3, right? Because x is negative 10 over 3 plus 9 equals negative 1. Let's see. So we're saying, so if we multiply 3 times negative 10 to the third, easy way to do this is to do the cross simplification. 3 divided by 3 is 1. So then we're left with negative 10 plus 9 equals negative 1. Let's see. Negative 10 plus 9 does indeed equal negative 1. So negative 1, this solution checks out. This statement is true, right? Okay, so here we go. I know I'm moving a little fast, but you guys can always, rewind if you need to, rewind the video. The last equation that I want to work with is one that shouldn't be that hard, but sometimes students find it a little challenging, and it's again because we're dealing with fractions, and I really want to encourage you guys not to feel too intimidated when you see fractions. We have an equation, linear equation that reads 12 equals 4 over 5 times x. Now, again, we could switch this entire quantity so that we're having the x on the left side because we're really used to solving it that way. We don't have to, but I find that it's easier for students to deal with that way. So we're just going to do that. And again, I haven't done anything, right? 12 equals 4/5 x is the same as 4/5 x equals 12, right? We're saying that this side is the same as this side. So that makes sense that we would just switch it around. So, for example, if I had a boy on this side, right, and a girl on this side, I could always switch it around. Girl on this side equals boy on this side. It doesn't change the meaning. It just switches the order, right, in terms of how we read from left to right. Okay, so anyway, coming back here. Now this one, you guys are like, what am I supposed to do, Ms. Chang? It's simple. We ask ourselves same thing. Step 1. Simplified expression on both sides. Yes, definitely. We've simplified it. Well, now let's then build the story of x. We've got 4/5. Sorry, I'm gonna really confuse you guys if I do this. Sorry, I don't know what I was thinking. Let me backtrack. Step 2. Let's build that story of x. I was getting ahead of myself. Let's build that story of x. Let's bring that simplified expression down here. It's 4/5 x equals 12. And basically what we have to ask ourselves is, what's happening to x? Well, we know that whenever we have a quantity, like a numerical quantity being multiplied to that unknown variable, or next to the unknown variable, the implication is it's multiplication. Okay, the implication is that the operation is multiplication. All right? So we just simply say, oh, well, if we're going to just build, it only seems like there's only one thing happening to x, and that is that it's being multiplied by 4/5, right? Okay, so to undo it, so this was building it, to undo it is to then divide both sides by 4/5, okay? So we're going to do this. We're going to divide, if you want to even do that, both sides by 4/5. Whoa, you're like, this is really tripping me up. So this is one of those rare occasions where I would say that you could also write 4/5 divided by 4/5 x equals 12 divided by 4/5. This is one of those few times that I would recommend that you do put in the division sign this way, because I know that you guys are used to doing the keep, change, flip, and so this form keeps that consistent. So you know that 4/5 divided by 4/5 is what? 4/5 change times the division to a multiplication, because we're dividing fractions. And of course we have 5/4 x, and that cancels out our fraction entirely. We're left with the x, but this time we got to go 12, and then we got to change that division to multiplication. We got to flip this, and x equals, now you could multiply 12 times 5, which is what, 60, and then simplify it by 4, and then you could do all that, and then figure out, well, what's 60 divided by 4? And if you guys are using calculators and it's easier to do that, that's fine. But another way for us to solve this is to cross simplify, because 12 times 5 is the same thing as saying 12 times 5 over 4, and we could always cancel these two out, right? So let me take this out. Anyway, the common factor between 12 and 4 is 4, right? So I got 1 here, 12, 3 times 5 equals 15. And if you use your calculator, or you do your long division and you divide 60 by 4, you'll find that simplified is 15. So now we're saying x is equal to 15. Well, let's see if that works. Let's check our work. We always can check our work with algebra. Okay, so 4/5 times 15 equals 12. Let's see. Well, we'll do the cross simplification again. 5 is a common factor between 5 and 15. 5 divided by 5 is 1. 15 divided by 5 is 3. And so then we're left with 4 times 3 equals 12. Yep, 12 equals 12.